Hello guys, welcome to Smart Interface YouTube channel. This is Aniket. Today we'll be solving problems from Starters 145 Division 3. So let's get started. Let's look at this question. Gun Master. You are given two guns, a close range gun and a long range gun. The close range gun can only shoot targets at a distance less than or is equals to d, while the long range gun can shoot only targets which are at a distance strictly greater than d. Okay, you can only hold one gun at a time. So initially, it's also given that you are holding the close range gun. You have to shoot n targets in order. The distance of ith target is A of I. Your task is to determine the minimum number of switches between the two guns to shoot the n targets. The input format is something like this. We are given t number of test cases. Each test case contains two lines. The first line contains n and d. N is the number of targets and d is the maximum range of close range gun. This second line of each test case contains n spaced integers a1 to n, which will denote the distances of n targets. Okay, let's understand the input. So here 4 is number of test cases. So we are given 4 test cases. Each test case has two lines. Let's try to understand this test case. So the first line contains n and d. N is equals to 4, the number of targets, and d is equals to 2, the maximum effective distance of short range gun. Then we are given 4 integers, the distances of targets. Okay. It is also given that we have to shoot the targets in order, in the given order from left to right. And initially we are holding the short range gun. Okay. So let's try to solve for this test case. So first we are having a target which is at a distance of 2. Now with a short range gun, can we shoot this target? Yes, because it is at a distance less than or is equal to 2, right? So there is no need of switching. Next, target at a distance of 1. There is no need to switch because it is under less than or is equal to 2. Next, 3. It is greater than 2. So we have to switch from short range to long range. Okay. The next target is 4. Now we are already holding the long range gun, so we don't have to switch. So the number of switches are 1. So the output is 1. Now let's understand this second test case and then we can start coding. So in the second test case, n is equals to 4, the distance is equals to 1, and given 2, 3, 4, 1 are the target distances. So first we have to shoot this target. So initially we are having a short range gun. See, the distance of the short range gun is at max 1. Now this is at a distance of 2. So we have to use a long range gun. So we'll be switching from short range to long range for the very first target itself. Next, this is greater than 1. So long range gun, we don't have to switch. Next, this is greater than 1. So long range gun. Next, the last target, which is at a distance of 1. Now this can be shot with the help of the short range gun. So we can switch. So how many number of switches? Short to long, then long to short. So 2 switches, right? So this is how we got 2. I hope this is clear to you. So what we can do for the very first target, we can simply judge if it is a long range or short range. Okay, short range or long range. Now we can look for the other parts, other targets. Let's say we consider this target. Now here we know we will be requiring long range gun. What we'll do, we'll simply compare it with the previous target. which will require long range gun. Okay, but initially it was a short range gun, so we had to switch. But from long range to long range, we are not doing any switching, right? So the number of switches at this point is zero. Okay, and when we come to this part, we'll require the long range, but previous target also used long range gun. Okay, so we don't have to switch. So this is how we can proceed. Let's try to understand this with the help of the code. Let's code it up. So first we are given n t number of test cases. So we have to look for t number of test cases. So I'll write a loop. Now in each test case we have two integers in the first line n and d. So we'll read them. Okay, so we have read n and d. The next line contains n targets. So we'll be storing them in a list, comma input dot split. Now we have the targets list with us. Let's declare a variable answer for storing the number of switches. Okay, we'll be looping. Let's say for I in range, then of the list. Now for the very first target, first we'll check if we can use a short range gun or not. Right? If list of I is greater than D, then we have to switch the gun. So answer plus is equals to 1. Okay. Now again, we can simply check for the other targets. Let's say the current target requires a short range gun. We have to check with the previous target if it requires a short range or long range. Okay. If list of I minus 1 is greater than 0, greater than D, that means we have used a long range gun for the previous target, and now we are requiring a short range gun. So the number of switches will increase by 1. Okay, and lastly, if the current target requires a long range gun, so this is nothing but list of I is greater than D. Okay, let's check the previous target. Now, if the previous target uses a short range gun, then the number of switches will increase by 1. And that's it. Now we can print the answer. Let's see. Look at the code. We are looping over the number of test cases. The first line of each test case contains n and d, then list of integers, then we are storing a variable answer is equals to 0, which will store the number of switches. Then we are looping over the list. Okay, for the first target, if the target requires a long range gun, we are switching the gun. And for the other targets, if the target requires a short range gun, but if the previous target requires a long range gun, we have to switch. So here it should be answer plus is equals to 1. And in the else condition, if the previous requires a short range gun, then we have to switch. So answer plus is equals to 1. Let's run this code. 1206, which is the expected. Okay, let's try to submit. And yes, so this is the code base. Let's look at this question. Make my array equal. You are given an array A of length n. Determine if it is possible to make all the elements equal by performing the following operation any number of times. Choose two distinct indices I and j, okay, such that I is not equals to j. Update the value at index I by setting A of I is equals to A of I plus A of j. Okay. For example, let's say the given array is this. We are choosing the indices 5 and 3. So this index, okay, so this index and the third index. Now we have to replace A of 5 is equals to A of 5 plus A of 3. 6 plus 3 is 9. So A of 5 will be replaced by 9. So this is what it gives. Okay. But if we choose the indices I is equals to 2 and j is equals to 4, it will result in this array. Okay. So ultimately we have to ensure that all the elements of the array are equal. We have to output yes if it is possible to make all the elements of the array equal, or else we can simply print no. So let's look at the input format. Given t number of test cases, each test case contains two lines. The first line contains length of the array. The next line contains a1 to an. So basically n integers. Let's look at the input. So there are three number of test cases. Now let's look at the first test case. Given the size of the array is 3 and 3 integers. Is it possible to make all the elements equal? See, it is already given that the elements are equal, right? Here, we can see that all the elements are equal. So we can simply print yes for this case. Next, let's look at this third test case. So 100, right? Here, let's say we want to make all of them equal and equal to 1. So this is already 1. We'll change this element. So this will become 1. Now how do we make it 1? We'll choose I is equals to 1 and j is equals to I is equals to 2 and j is equals to 1. Okay. So we'll be choosing I is equals to 2 and j is equals to 1. Assume that we are using 1 based indexing over here. Okay. So if we do that, we'll add this to this element over here. So it becomes 1. Now these two are sorted. These two are made into 1. So these two are made equal. We have to make this to 1. How do we do that? We can choose any one of these two and make it 1. So this will also become 1. At last, we have made all the elements equal. Okay, so we'll simply print yes. Now let's look at the second test case, which is this 2, 1, 2. Now here, let's say we want to make all the elements equal to 2. Okay, now here we know that this is already 2. Can we make this 2? We cannot make it 2, right? Because if we add 2 to this number, it will become 3, which is greater than 2. Now can we make it 3 instead? Can we make all of these equal to 3? Let's see. Here, the second element is 2. We can simply add it with the first element, so this will become 3. And what about this? If we add 3 to this element, this will become 4, right? So we cannot make both of these to 3. So similar way, there is no possible way to make both of them equal. So the answer is no. Let's generalize this and then try to understand this with the help of a small example. Okay, let's say you are given an array of size 3, let's say 1, 2, 3. Now when we want to make it equal, let's say we want to make all of them as 3. This is already 3. To make it 3, we can simply add 1 to this number. So this will become 3. Now can we make it 3? See, both of them are equal to 3, right? Both of them are equal to 3. If you add 3 to this number, this will become 4, right? But all of them not will not become equal. Okay, so the resultant will be something like 433, which is not equal. So by now you should have observed that. So let's say we have this array. To make it equal, there is at least one number left out at the last, which we cannot make equal to the other numbers, right? Unlike the example, this where we have zeros. Okay, now we can make all of them equals to 1 by simply adding 1 to these numbers, which is the given element. Okay, now similarly, if we have the example 500, 500, 5, 5, can we make all of them equal? Yes, right? To this, we can add any one of these three elements and make 5. Similarly to this also. So both of these will become 5 and all of them will become equal. So when there is a 0, it can be easily handled, right? So 0 is not an issue at all. Just that the case when there are multiple numbers, distinct numbers, there is at least one element which is left out at the last. Okay, so we can generalize it from here. So we'll simply divide it into three cases. If all are same, if the given in the given input all are same, then we can say yes. Okay. Now we know we can simply handle the zeros case, just that we have to handle the other numbers. If other than 0, there is only one distinct element, there is only one distinct element, we can say we can always make all of them as 0, right? All of them equal. So in this case also yes. But if we have two or more than two distinct elements, so distinct is greater than 2 except zeros, we cannot make them equal. Okay, so based on this we'll get our answer. Okay, let's try to understand this with the help of a code. Let's look at the code. So the first line contains the number of test cases. We'll loop over the number of test cases. Each test case contains the number of integers followed by the integers. Okay. Now here talking about the number of distinct elements. How we can find the number of distinct elements? We can simply make use of a hash set or a hash map. Okay, let's say we are using a map of type integer. Now we'll be storing all the elements into the hash map. We'll scan the element. Now we know that when the element is 0, we can simply make it equal to any other element in the array. Okay, so we'll simply consider the elements which are not is equals to 0. So we'll be adding this to the hash map. So map of temp plus plus. Now after doing this, after adding all these elements to the map, we can simply check the size of the map. Okay, if the size of the map is 0, what does it mean? There are no elements except zeros, so all the elements are zeros. In that case, we can surely make them equal. Or the other case is that when there is only one element, one distinct element. Okay, in that case, we can say we can make all of them equal. So map dot size equals to 0 and map dot size equals to 1. Print yes. If the number of distinct elements are more than 1, that is 2 or more, we can simply print no. Okay, let's try to run it. Yes, no, yes. This is expected. Let's try to submit. Right? So this is the code. Let's look at this problem. Make Bob win. Alice and Bob are playing a game. They have a binary string S. Okay, a binary string is nothing but a string having zeros and ones as the characters. Alice and Bob alternate making terms. So they are taking alternate turns with Alice going first. So Alice is making the first move. On the turn, choose a non-empty contiguous substring of S, all of whose characters are same, deleted from S and concatenated with the remaining part. Okay, so let's say this is a binary string. So what a person in return can do is choose this contiguous part, remove this, and we can simply concatenate the remaining part. So the updated string will look something like this. So this is the move that both of them can do. So Alice wins immediately when S does not contain any occurrence of 1. So let's write it over here. So Alice wins when there are ones, while Bob wins immediately when S does not contain any occurrence of 0. Okay, so he wants no zeros. Both players play to win. What does it mean? See, Alice wants all of them to be 1. That means she will remove all the characters. Alice wants all the characters to be zeros, right? Because no ones means she will win. Okay. So she will be removing all the characters which are equal to 1. So she will remove ones, all the ones, and in the case of Bob, he will remove zeros. Okay, because He wants all as one to win. Bob wants to win the game. So before the start, he can flip some of the characters. And also it is given that if the string does not contain any occurrence of zeros, Bob will win before any move. Okay, if the string is initially having all the ones, Bob will win. And Bob wants to win the game, so before the game starts, he can flip some characters of S. Okay, so he has an option to change the string before the game starts. Okay, so what he can do is, let's say, so he can choose some of the characters and flip them, right? So he can choose this character and change it so that it becomes 1, right? He can choose this character and change it to 0. Okay, but as we know, Bob always wants to remove zeros, so he'll only choose the characters which are equal to 0, right, to make this one. So the updated string will become something like this. Okay, so these are the moves. This is the move that Bob can do before the game starts. Find the minimum number of flips Bob needs to ensure he can win. Okay, so he wants to win, and we have to find the minimum number of flips to make Bob win. So the input contains the number of test cases, number of size of S, and the string S. Okay, so Alice wants to remove ones, Bob wants to remove zeros. Okay, if we take this example, the string contains only 0, the length is 1, and the string contains only 0. In this case, Bob will win. So even before the game starts, he will try to manipulate the string. So he'll simply remove this and Bob will win. Okay, so we'll simply make it 1. So this is the flip that he can do. So the number of flips will be 1. If you consider the second test case, the string is something like this. In this test case, all are ones, and as per the question, it is given that if it does not contain any occurrence of 0, Bob will automatically win. So in this case, it does not have to make any changes to the string, and he will win. Okay, so 0 changes, 0 flips, and Bob will win. The third test case. So the third test case is something like this: 0, 1, 1, 0, 0, 1. Okay, let's take a bigger example for you to understand. So let's say the string is something like, okay, if the string is something like this and it's Ali's turn, let's say she is making the turn. So what she will do, she can choose the substring with ones and simply remove it. Okay, but as she wants to win, she wants to minimize the number of ones in the string. So she will take all these and remove it once. Okay. Similarly, if Bob is going to do the turn, right? So Bob will remove zeros. Bob will remove the zeros. So we can say he'll not just take one character or two characters or three, but he'll take all of these at once and remove them. Okay, so that he can ensure his win. So from this we can say this will take one turn, this will take one turn, this will take one turn, 1 and 1. Okay. So all these will take only one turn. These three will take one turn. Okay. So even let's say there were 5 characters over here or 10 characters. All of them would take one turn, right? But even if there is only one character, it will take one turn. Okay. Does not matter how many zeros are there. All of them will take one turn. So let's say for you to understand, I want to compress the string. So after compression, it will become something like this: 1 0, and then 1 0 1 0 and 1. Okay. So I'm compressing the string, so I'll get 1 0 1 0 1. Okay. Because anyways, it will take one turn each, right? Now in this case, let's say the string is unaltered by Bob, and Allah is going to take the first turn. Okay. If Allah is going to take the turn, she will remove once. Let's say she is removing this. Next, Bob will come up and he will remove this 0. Then Alice will come, she will remove. Then Bob will come. Then automatically only one is remaining, which will make Bob win. Okay. But let's say the string is something like this. Okay. So in this case, what is the complete string? 0, 1, 0, 1, and 0. Okay. So in Alice's terms, she will remove this. Bob will remove this. No. So Alice is going to remove once, right? So Alice will remove this. Bob will remove this. Okay. So you can remove this. Then Alice will remove this. And then you'll only have 0. So ultimately, Bob will lose. Okay. In this case, Bob will lose. So over here, if you observe, each of this part is taking one turn by each. You know, when we want to remove zeros, Bob will do this, Alice will do this, right? Alice is removing 1. So Bob will do this, Alice and Bob. From this we can say Bob will require 3 turns to remove all zeros. Alice will require only 2 turns. As they are playing alternatively, Alice Bob, Alice Bob, Alice Bob, and so on. Alice will complete these first 2 turns, and then Alice will complete these 2 turns first, even before Bob completes the last turn. So Alice will win. Okay. So it's all about the number of turns. Okay. But instead, let's say the string is something like this. Here we have one, here we have one. Alice will take this turn and this. Okay. So in this case, we can say Bob will require 3 turns, Alice will require 5 turns. Now, as we know, if they play alternatively, to do these 3 operations, Bob will complete these 3 operations even before Alice completes 5 operations. So in this case, we can say Bob will win. Now, when we compress the string, it is for sure that we have this alternatively. Okay, we have this alternatively. So we can simply count the number of turns. Now, in this case, Bob will win. Now, when it was 5 and 3, we know Alice will win. So we can simply compare the number of moves. Okay, number of turns. Now, let's say If the string is something like this, Bob, Alice will remove once. So this is Alice. Alice two turns, Bob two turns. But who will win? Okay. So we can say here Alice will remove this in the first turn, Bob, then Alice, then zeros will be left, and then we can say Alice will win in this case because Alice starting first. Alice is starting first. She will complete the second turn even before Bob completes. Okay, so to make sure that Alice lose and Bob win, we have to make sure Alice has more number of turns than Bob. Let's consider an example and then we can jump for coding. Okay, see here the compressed string will look something like this: 0 1 0 1 0 1 and 0. Okay, 0 1 0 1 0 1 and 0. Over here, Alice will take less number of turns, Bob will take more number of turns, right? So Alice will win. But if Bob will change this to 1, we'll have a 1 over here. So the number of turns required by Alice will be 4 and the number of turns required by Bob will be 4. But even in this case, can I say Alice will win? Because she will be starting first. She will be starting first, so she will be win. Because we have the order something like this A, B, and so on. So Alice will complete first and she will win. But let's say if the string is something like this, if I have a 1 over here, then the compressed string will look something like this: 1 0 1 0 1 0 1 0. Both of these are ones, so 1 over here. Okay, over here, how many steps Alice will require? She will require 4 turns and Bob will require 3 turns. In this case, the number of turns required by Bob is less than the number of turns required by Alice to win. Okay, so in this case, we can say Bob will win. I hope this is clear. Now, when will this happen? This will only happen. Number of turns by Bob will only happen when the first term and the last terms are one. Only if this happens, the number of turns by Alice will increase and the number of turns by Bob will decrease. Okay, so let's say this is a string. 1010 is the compressed string. Here, to ensure that Bob wins, he will simply make the last term as 1. So in the compressed string we'll have 10101. Okay. Even if the string is something like this, Bob will simply change it to 1. So we'll get the compressed string as 1010 and 1. So Alice has to make 3 turns and Bob has to make 2 turns to win. Okay. And in this case, 01010. Okay. This is the compressed string. Here, Bob has to make more turns. To ensure Bob wins, Bob will simply change the first and the last. Okay. Now he'll always try to make the first and the last as 1. Okay. If it is already a 1, no need to change. But if it is 0, he will change it. So he'll either require 1 turn, 2 turns, or maybe in this case 0 turns. Okay, so the compression will become something like this. So 0 turns over here. So the maximum is 0. So 0, 1, 2 are the required turns. Okay, required number of flips. So the logic is to turn the first and the last character to one. Okay. So if it is required, he will flip it, and based on that, he will win. Let's try to code it up. Let's try to code it up. First line has the number of test cases, and each test case has the first line has the length of the string, and then the next line is nothing but the string itself. Now, if the length of the string is only one, and let's say if the character at 0 is 0, that means he has to flip the bit. So there is only one bit, so he'll simply flip it. Else if the character is already 1, we can simply print 0. If the length of the string is not equals to 1, then he'll check the first and last character. Let's take a variable answer to count the number of flips. If the first character is 0, he has to flip it. So answer plus plus. If the last character is last is n minus 1, if it is equals to 0, he has to flip it. Okay, now we can simply print the answer. One zero one, which is expected. Let's try to submit. Yes. So this is the code, guys. For the problem, make Bob win. That's it for the video. Thanks for watching. If you want to learn problem solving, join our 3-month Smart Coder course and master data structures and algorithms. Link is in the description. Until the next video, this is Aniket Deshmukh signing off.